Okay, dear children, now in this video we will see how to solve the questions that are given in exercise 2.1. Okay, so let's start with question number 1. Okay, identify the prime numbers in the list. So we have already discussed in the previous video that prime numbers are those numbers which have only two factors, okay, 1 and the number itself. Okay, so the first prime number is 5, okay, and 23. Second one is 23. Okay, 27 is not a prime number because it has more than two factors. Okay, like its factors are, okay, 1, 3, 9, and 27. So it has four factors. So 27 is not a prime number. Now 73, yes, 73 is a prime number because it has only two factors, 1 and 73. That is the number itself. Now 77, 117, and 136 are also not the prime numbers because they have more than two factors. Okay, so from the question number 1 we can see that there are only three factors, three prime numbers, that is 5, 23, and 73. Okay, okay, so now from question number 2 we have to identify which of the following numbers are co-prime. Okay, so we have already discussed in the previous video that co-prime numbers are those numbers, okay, or the set of two numbers which has the difference, which has the common factor of only 1. Okay, so you can see that the 7 and 3, it's a co-prime. Okay, now in B, it's not a co-prime number. Why? Because it has the common factors of 1, 2, as well as 4. Okay, so it is not a co-prime number. Okay, now in C, question number C, 33 and 35. So 33 and 35, this set is a co-prime number. Why? Because there is a common factor of only 1. Okay, and again in case of question number D, it is not a co-prime number. Why? Because 11, okay, including 1, okay, 1 and 11 are the common factors. So it is not a co-prime number. Okay, and in question number E, 64 and 169, yes, it is a co-prime number. Okay. If you have any confusion in question number 2, you can contact me. Okay, I will show you in a different way. If you still have some doubts out here in question number 2, okay, feel free to contact me, please. Okay, now let's move on to question number 3. Now calculate the value of the following. Okay, now first question, that is question number 3A, 3 to the power 5. Okay, now 3 is repeating itself for 5 times. Okay, in the previous video I had shown you this prime factorization like this. See, 2 is repeating for 5 times. Okay, so hence we can write 2 to the power 5. Okay, so we just have to go back to this step. Okay, from the exponential form we have to represent it as prime factorization. Okay, so 3 is repeating for 5 times. Now here in this particular case I have made like this. I have highlighted with red and blue. Okay, so 3 to the power 5 times. Okay, so 3 is repeating itself for 5 times. Okay, so I have made a pair out here. Okay, this is a pair of 3 numbers. Okay, 3 threes, and this is a pair of 2 threes. Okay, so now 3 threes are 9, 9 threes are 27, and again this one 3 into 3, it will be 9. Okay, so 27 into 9 times it will be 243. Okay, and similarly in question number 3B, 5 is repeating itself for 4 times. Okay, so 5 to the power 4, 5 is repeating itself for 4 times. Okay, So now the first pair, 5 5s are 25. Okay, and the second pair, that is 5 5s are 25. Okay, we can do it like this, and 25 into 25, it will be 625. Okay, it is not compulsory that you have to solve it this way. Okay, you can solve it whatever the way you feel like. Okay, but it should be remembered that any number has got the power. Okay, that is power of 2 or 3 or 4 or 5. It means that the number itself is repeating for that many times. Okay, now in question number 7, we can see that 7 to the power 3, that is 7 is repeating itself for 3 times. So 7 sevens are 49. Okay, now 49 into 7 will be 343. Okay, similarly, you will solve question number D and question number E. Okay, again, I want to repeat that you don't have to follow the way that I have solved out here. Okay, you are free to multiply. Okay, as per your way of convenience. Okay, in the rough copy. Okay, or in the rough area of your classwork copy. Okay, so here in question number D, you can see that 3 is repeating for 2 times, 3 to the power 2. Okay, and 5 is repeating for 3 times, that is 5 to the power 3. So if you open this up, it will be like this. Okay, so 3 3s are 9, and 5 into 5 into 5, that is 5 3 times, it will be 125. So if you multiply these 9 and 125, you will get the answer 1125. Okay, and in the last question, that is 3E, we have 2 to the power 3, that is 2 is repeating for 3 times. Okay, and 4 to the power 2, that is 4 into 4, and 5 to the power 1, which means 5 is repeating only for 1 time. Okay, so we will write only 1 5 out here. Okay, so 2 into 2, 4, 4 2s are 8. Okay, you will get 8. Now 4 4s are 16. Okay, and you will bring this down 5. Okay, now 16 into 5, it will be 80. We already know this. Okay, so now 8 8s are 64. So just include 1 0 out here. Okay, so this way you can multiply this. Okay, the way you feel comfortable with. Okay, please follow that. Now let us move on to the next question. That is question number 4. Okay, so it's fill in the blanks. Okay, fill in the blanks with the terms factor, multiple, prime, co-prime, or composite. Okay, so now if 33 into 3 equals to 99, then 99 is a dash of 33. So 33 is being multiplied with 3. Now let me show you here in this picture. Where is that? Okay, so now any number, okay, that is multiplied for with 1 or 2 3 4 5, okay, you get something. Okay, you get a result out here. Okay, and that result is known as multiple. So the first answer will be multiple. Okay, now in the next question, you can see if 11 into 4 equals to 44, then 11 is a dash of 44. So 11 is a dash of 44, which means 11 is a factor of 44. Factors and multiples, they are closely related to it. Okay, if you multiply any given number and you get some answer, that particular answer is known as a multiple. Okay, but these are your factors. So now if anyone asks you 4 multiplied with 3, we get 12. So 12 is a multiple of 4. Okay, you can also say 12 is a multiple of 3 also. Okay, because 3 into 4, it will be 12. Now 4 into 3, it will be again 12. Okay, but 4 and 3, they are the factors, because 12 can be exactly divided by 4 and 3. Similarly, in question number 4b, 11 can divide 44 exactly, hence it is a factor of 44. That is, 11 is a factor of 44. Now question number C. if 13 into 5 equals to 65, then 13 and 5 are dash factors of 65, which means it is a co-prime, because factors of 13 will be 1 and 13, and the factors of 5 will be 1 and 5. Hence, there is a common factor of 1. Hence, we can say that 13 and 5 are co-prime factors of 65. Now, if 15 into 5 equals to 75, then 15 is a dash factor of 75. So 15 is a dash factor. So what type of factor it is? It is a composite factor. Why composite? Because it has more than two factors. The factors of 15 are 1, 3, 5, and 15. So it has 4 factors. Okay, but we already know that for prime factors, there should be only 2 factors. Okay, for any prime number, the factors is to be only 2. Okay, 1 and the number itself. But for 15, we have 4 factors: 1, 3, 5, and 15. Okay, the number itself. So it is a composite factor. Okay, and 5 is a dash factor of 75. 5 is a, sorry, it's not co-prime, but it is prime. Okay, it's to be prime. Now 5 is a prime factor of 75. Why? Because 5 is a prime number. Okay, uh, because 5 has only 2 factors, 1 and the number 5 itself. Okay. Now, along with this PDF, I will be sending you the solution of question number 5 and 6 also. But I want to make a separate video for the explanation of question number 5 and 6. So I want you to go through this particular video and the next video that will be uploaded. Okay. For question number 5 and 6 from exercise 2.1.